All right, so we were talking about text files. Hey, someone else is here. Wonderful, yeah.
You made it.
We're only 20 off of the number of people in the class still. All right, so text files. Awesome. What are text files? Well, we were talking last time. It's like the most basic way to get text into a file, right? The .txt, it doesn't really mean anything, but like it tells the computer, okay, yeah, great. And I'm just writing stuff in here. It's not fancy. This right here is, it's kind of like even lying. I don't even think we can boldface things. Yeah, things to do. From text to note, emphasize your text, bold this, notes, whatever. Basic text file. This is a text file. I love text files. See, nothing but text. Woo, fun, blah, 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 blah. Cool. All right. Oh, save as markdown. No, save as text file. Because it was going to lie. It wasn't going to be a text file. It was going to try to change it to markdown. Okay. Anyways, long story short, a basic text file. Okay. Just text. What do we see? Something, whatever. New line, more stuff, new line, more stuff, new line, blah, blah, blah. Okay, cool. I'm going to save it. And right now, I have it saved to my desktop. It doesn't matter really where I save it, but I've got it there because it's going to be easy to access for later. All right. Yeah, like I was saying, okay, files are a great way to store textual data. They typically have a file extension .txt, but it doesn't actually really matter. Most of what we are about to see will work with many different file types too, not just text files. All right. Now, again, just to make sure I hit the point hard, why do we care about this? Well, imagine you have like a crap ton of data that you want to enter in the computer, like assignment 1, the latitude, longitude pairs. You're not going to want to sit there and enter each thing with the input function, right? You want to load it all up like that. So we can read from a text file. Awesome. And how do we do it? Here. Very easy. This code right here. If I type this, but if I run this, it's not going to work. Who can tell me why it's not going to work? The file doesn't exist. I got to upload the file into Colab. And if you didn't notice, every time you reopen like your Colab thing, you got to re-upload any file. Awesome. Okay, perfect. And it's going to say it's not going to be saved. Great. I hit run. No, what are you talking about? It's right there. Oh, it's because it's not called that. It's called this is stuff.txt. There. Awesome. Also, a word of advice in general, just to make things a little nicer. It's not really going to matter here, but let's rename. In general, it's kind of good to not have spaces. It might just make your life a little easier. So I'll just change it to underscores there. Okay, cool. Great. So what does this line of code do? Oh, also, let me zoom in for you. Is this reasonably good size? You know what, let me lower the lights back there. It kind of washes out the projector, I think. There, that's a little better. All right, so I'm creating a variable called myFile. Note that this isn't going to be the text. It's going to be the file. And then from the file, we can get the text, but we'll see. So what file are we going to load? Well, how are we going to do it? Okay, we use this open function. Then we give it a string, which is the name of the file. Okay? This is stuff.txt. If I type it in wrong, it's not going to work because it's going to say there's no file. I don't have that file. So there we go. Great. And also, we've got this little R here. Now, this is actually kind of like from an old way of doing it, but it's stuck around. Anyone want to guess what the R means?
Read only.
Read mode, exactly. We're going to open up this file in read mode, meaning all we want to do is get information from the file. We don't want to worry about writing information to the file right now. Okay? So there we go. So yeah, this opens it up. Whatever, read mode. This assumes that the file being opened is in the current working directory. A reference to the file is stored in the variable myFile. Now, here I'll give you a few minutes to try this activity. What I want you to do is create a text file, upload it to Colab, open the file just like this, but then I want you to play around with things like, well, myFile dot, and you'll see that this is an object with a bunch of methods attached, and also fields, or whatever we call them in Python, attributes. But I want you to play around with what you see here, specifically maybe read line and read or something, to see, and if you can figure out how to read it all. Okay, so just play around for a few minutes. I want to give you a chance to hack around, see if you can get this working. All right, so have fun. Who tried read line? And what did it do? It read a first line. Well, that's perfect. Awesome. Anyone try read lines? Anyone try that one? That one was a little different. That one, it looks like what it does is it gives you a list where each element in the list is the contents of each line, which is kind of nice, right? Reads it line at a time. All right, neat. Did anyone just try read? Read, we'll just read the whole contents and return a string of the whole contents. Now, what's neat here is you'll notice that, like, if we go back to this one, you can see that we've got those like special escape characters here to mean like new line, da 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 da, new line, right? And then there was a blank line, so just a new line, right? So that's kind of neat. But when we do it like this with read, oops, you don't see the new lines as escape characters. You actually like see them as like a thing there. But if I were to just say thing, right? If I don't print it out, it's because of how Python wants to format long strings. It'll actually like print out the new lines as new lines. But if we just like observe it by just saying like thing, right? We can see that it's got like all that extra stuff in there, right? So it's still there. It's just it's how it's being like displayed to you. Long story short, probably the easiest way to read all the contents of a file is with read. Yeah. Awesome. Read lines can be nice if you want to like, because if you get a list of each line, maybe you want to do something to each line. So maybe like that a for loop would be really nice. Let me show you what I mean. If I say read lines, and then for a in thing, print a, right? Right, so now it works, right? But it just prints out each line like one at a time in that loop. It also adds extra spaces, and the reason it's actually, can anyone tell me why it added extra like white, like extra lines? There's no trick question here. It's because, like, if we were to look at, okay, print a thing. Okay, so look at this string here. This is stuff, new line. So print will go out and say, this is stuff, new line, but then print also adds a new line. Okay, so it's effectively added an extra new line at the end, by the way. Anyways, I'm just showing you this stuff here. So if I were to say thing equals, oh, hold on, no. Pay attention, like check this out too. This is a funny thing. Okay, print thing, okay, makes sense. And then let's say like thing, let's do it again, my file.read. Okay, so I'm gonna read from the file again. Oh, you have a question?
I was wondering about the /n's. Are those there because in a text file, when you like go down to a new line, so it just like puts it there?
Well, it's because as far as like the string is concerned, like how do you represent a new line in a string? You can't, right? Now, like you'd be like, what, you print it out? Well, that's different. That's not like a string data type stored in Python. That's like what it's displaying to you. So that's how we encode into a string that there should be a new line there. Okay. So when Python goes and sees like /n, when you print it out, that /n will be turned into a actual new line. That's what's going on.
Okay, thank you.
So let's be clear what I'm trying to do here. Print thing 2. Okay, so what am I doing? I'm opening up the file. I'm reading its contents, putting it into thing, printing out thing. That's what we saw here. And now what I'm doing though is I'm going to like, okay, do it again, put it into thing 2, print out thing 2. All right? So how many times, based on what you just see here, how many times do you expect to see this? It's not a trick question. Once. It's not quite the same thing. That's not why. It's because when you read from a, and so how would you know this? You wouldn't, okay? It's by virtue of how like the files work, okay? When you read from a file, think of the file having like a little robot in it, okay? That starts at the beginning. If you read a line, it reads one line and then goes to the next line. If it reads all the lines, it goes like do, 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 do. Or if you read the whole file, it's going to go and get to the end, okay? And now that robot is at the end. If you say read again, that robot doesn't go back to the start. It'll be like, okay, continue reading from where you are. Oh, I'm at the end. Read more. I'm at the end. So it won't go back to the start. So then you ask, how do I get back to the start then? Open the file again. If you really need to, open the file again. There, okay. That'll reset that little robot at the front. Cool? Pretty neat. Just the way it works. Next semester, we'll learn a little bit more about like, wait, what? This is a next semester thing. For now, it's just some trivia to know. If you read from a file and you want to read from it again, you got to start over. You can't go back. You got to just open the file again and start again. The easiest way to not have to like, well, what if I need to keep reading from the file? Don't. Read from the file once and save the contents somewhere, right? So like I could fix this by saying like thing 2 equals thing, you know, whatever. So ideally, you don't want to read from the file multiple times. In fact, file I/O is really slow for a computer. In a similar way that like, remember how, like you might remember, like did I show you this? For I in range, let's do like print I, okay? Oh, I didn't, 4. It's go, okay, that actually went pretty quick. Let's add another 0. Okay, let's add another 0. So you can see down here, it's actually like counting 4 seconds, 5. It took like 5 seconds, okay? Let's add another one. See, 2 seconds, 3 seconds, 4, 5, 6, 7, 8, 9, and so on, right? You see, this is how long it's like running. And what am I doing? I'm just counting up, all right? And like, what number is this? That's 10 million, okay? And you might think, well, okay, I guess counting to 10 million will take a few seconds for a computer. No, it won't. But then why is this so slow? I'm going to stop this now, okay? Why is it so slow? What's slow isn't like the counting. What's slow for a computer is printing it out. That's really slow. It's also slow to read from a file and write to a file. So that's what's slow. And I can prove it to you by saying like, okay, if I'm going to add extra work by adding like a line of code, right? So a line of code needs to be evaluated. Mod. Here, what I'm going to do is I'm only going to print out the number, like the every 1000th number, okay? Still taking a while. Maybe it's still going to be slow. Maybe I should do like every 10,000th. Let's do every 100,000th number.
It needs to be if it equals 0.
Thank you. Boom. There we go. Done. Done. So because we're printing way less, it's going to go way faster. Right? Cool. FYI. So that's actually what's slow. The computer can count to 10 million pretty freaking fast, actually. It's the printing that's slow. More on that in a moment. That's important for when we learn about writing to files. All right, cool. And also, by the way, it is important, not so, I mean, okay, look. Whenever you open a file, close the file when you're done with it. Okay, how do you do it? myfile.close. Cool, there, that's how you do it. In practice, for what you're going to be doing, forgetting to close a file that you open for reading purposes, not that big of a deal. However, forgetting to close a file that you're using for writing purposes, that can turn into a giant nightmare, and I will show you why in a moment. But any questions about what we're seeing right here? Reading from a file. There's some data in the file. I read it up. Good to go. Okay? Yeah? Yeah.
Is there a way to like print a specific line of a file, or is that just kind of?
Well, in that case, what I could do is like, yes, we can by saying like read lines, right? And then I can say thing at line number 3, right? So like I can read the lines. Each line gets in its own list. Or sorry, each line is its own string in a list. And then each line number, like here, look, right? So the list at index 0 is the first line, next line, next line, next line, next line, right? So that would be an easy way to do that. What if I do like read line 3? I think that, okay, no, that's only going to read the first 3 letters of the line. Okay, yeah, cool. There's a lot you can play around with. Sky's the limit. Play around with it. It's the best way to learn it. Other questions? Okie dokie. So now writing to a file. Okay, if we could read to a file, we could probably write to a file. Now, what's neat about this is, perhaps obvious, when reading from a file, the file has to exist, right? Right? Makes sense? But if I'm going to write to a file, the file doesn't need to exist. It's fine, right? Because like it'll create the file, okay? Now, okay, my other file is open another file name .txt. Who wants to guess what W means? Right, cool. There's a bunch of options actually, but these are the simplest ones. So if I have this, watch, I'm going to hit run. Okay, now look. This I'm going to refresh over here. Boom, it exists. It's there. It was already there. If I didn't refresh, like I need to tell it like, okay, update, are you seeing anything new, right? And I can click this actually in Colab, and it'll show me the contents of that file. There's nothing there. In fact, I could do this with the other one, and there is stuff there, right? But whatever. This is the other one. Cool, nothing there. Awesome. Awesome. All right, unlike reading, the file doesn't need to exist. It'll create the new file. The most common used methods that you're likely going to see is like write or write lines, okay? Write will work by like, well, you just give it a string and it'll write. Where write lines actually takes a list of text. Kind of think of like the read lines, how it takes a list of strings, or sorry, it gives you a list of strings where each string is the line. This will do like the inverse, right? You give it a list of strings, it'll write each string on each respective line. Pretty neat, right? Cool. But write and write lines are probably going to be the most common things you would use. This is saying, yeah, do it. Okay, cool. Yeah. So, yeah. Take 3 minutes and do one on your own, right? And then once you're done writing to it, like open it up and confirm that you did in fact write to that file. Okay? You should like just open it up and do it. Okay? So take a few minutes and try that as well. What's up? Pardon?
I haven't understood the assignment you're trying to tell us how to.
Sorry, I can't really hear you.
Okay, like how should I add like?
Oh, well, you just call it like a function and give it like a string. Like hello. like that, yeah. All right, who here got it working? Who here thought they got it working, but it didn't seem to actually work? All right, cool. I'm curious if you followed the instruction, those people, but we'll see. I'm gonna find out. So if I say like my other file dot write hello world, and I hit run, right? And I go to another file name, there's nothing in there. Maybe it's I need to refresh. Nope, nothing in there. Who here had this happen? Yeah. You didn't follow the instructions. I'm willing to guess you didn't do this, did you? You did? I don't believe you. My other file dot close. All right, run. No, okay, let's. There we go. It's finally there. Why? Well, closing your file when you're done writing to it is incredibly important. And the reason it's important is by how file I/O is designed. You might have remembered that I just finished saying printing to the screen is really slow for a computer. Writing to a file is really slow for a computer. And what's slow is like the opening and writing, opening and writing, opening and writing, opening and writing. That is slow. So what happens is, how writing to a file actually works is when you write a line of code like this, you're being misled. This line of code does not write to the file. What it does is it writes to a buffer. And all that means is, what I'll do is every time I write, I will add things to the buffer. I won't add it to the file. I'll add it to a buffer. Think of a buffer as like a list, okay? Every time I write something, I append a new thing to the list, okay? Then, every once in a while, or like when you close the file, we will flush the buffer, which means take everything in that buffer, open the file, and write all of those little things all at once. So instead of like writing to a file, like let's say I wanted to write to a file the numbers 1 through 1,000,000, okay? That would mean go, open the file, write to something. Okay, open the file, write, open, write, 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 1,000,000 times, right? Correct? Yeah. Instead, what we do is we add all that stuff to a list, and then when we're done, we open the file and do one big write. Doing one big write is a bajillion times better than 1,000,000 little writes. That's why you got to close the file to flush it. You actually don't need to close it. There's also a flush that will also do, flush, that will also do it without closing, but closing is just as good as anything else. So that's why it's actually really important to close your files. This, I'm willing to bet, if you carry on doing computer science, this right here will bite you in the ass multiple times in your life. I don't even want to admit how many hours probably trying to figure out what was wrong with my code when it was really like everything was right, except I just didn't close my file, so the buffer was never flushed and data was missing. Giant nightmares will happen. Always close your files when you're done with them. That's the moral of the story here, okay? Any questions about writing to a file? All right, cool. Yeah, so this is what I'm saying. Yeah, okay, let me make sure I didn't miss anything. It's very important to close your files. When you are done with them, especially when writing to a file, like I was saying, when you're reading from a file, not that big of a deal. It's when you're writing where it's a problem because like the flushing thing. Basically how Python writes to a file, the contents you write are not sent to the file right away. Instead it goes to something called a buffer that periodically writes to the file. If you fail to close, there's a chance that your buffer never finished writing to the file before the program terminated. When you close, you force it to flush the buffer, like I just said. Cool? Cool. Always close your files. That's it. Otherwise, you will be hunting down a bug somewhere that doesn't really exist, and the bug is ultimately just you didn't flush your buffer. All right. Next, I'm going to talk about CSVs. CSVs, look, often when you want to load data into Python, if you're doing like any like data analysis, a lot of the times data comes in like tabular format, right? Like think of like an Excel file, right? Where you've got like rows and columns or like tables of information, right? It's not like just a text file. Yeah, it's like a text file, but it's like a little special. So because this is such a common thing, there is a common format called CSV for any like tabular data. Tabular being like not the tab button, but like tables, okay? Think of rows and columns in a spreadsheet. CSV styles are ultimately stored as plain text, but they'll have a different file extension called like CSV. And what happens is, in your file, each row is a line, and each column is separated by commas. I'll show you a quick example. If I go back to my text file, and I do like A, B, C, D, E, F, G, H, I. Okay? And by the way, I'm pretty sure in assignment 1, the latitude, the Starbucks file was a CSV, right? So here we go, like that. In fact, I'm actually going to rename this. Here, let me undo. Save. Save as. And I'm going to call it .csv. Cool. There. Blah.csv, there it is. Okay? Just like that. By the way, here's a neat little thing. You'll notice that, like, well, I saved it to the desktop, but you'll notice that because it's a .csv, unlike a .txt, because it's a CSV, and I have Excel on my computer is like, hey, you can open up that CSV in Excel, right? And I can do that, right? I'll just do that real quick just to show you. I'm opening it up. Now, don't get it confused. This is not an Excel file. You can't type in formulas or anything. Yeah, okay. Close, go, sure. Okay, what am I agreeing to? Whatever. You'll see like, oh, it like displays it like a table, right? Each line was a row. Each column, well, there was a comma between each one. So there you go, right? It's not an Excel file. As soon as I try to say like equals whatever, it's going to be unhappy. And maybe Excel will be like, do you want to save this as an Excel file? Also, if you have an Excel file, you can, like, save as CSV. You'll lose any fancy stuff, but you can save things as a CSV, too, from Excel, which is pretty handy, by the way. But, okay, just go away. Who cares? Anyways, CSV, yeah, don't save. I don't care. Cool. There we go. Awesome. Now, I'm going to upload this to Colab. Upload from desktop, blah.csv. Okay, if I open it, and what's even nice about like Colab is if you, like, look, if I open a text file, you just see the text eventually. Whatever, that one had a hard time. Here, we just see the text, right, in the file. But because it's a CSV, it knows like, oh, okay, I can kind of like show it to you like this. Even though within the file, if I open up the file, I see A, comma, B, comma, C, right? Colab is saying like, well, here, I mean, I know what you want it to look like. It looks like that, by the way, which is a pretty neat little thing, a neat little feature of Colab. Awesome. All right, so here's the CSV. And by the way, you can read a CSV file just like your regular text file and parse it accordingly. It's entirely fine. Think about it. You could like read lines and then like split each line on commas. Right there, you've got like that data, right? Cool. But because CSVs are so friggin' common, there's a built-in thing for CSVs, right? So let's say I've got this one here. I'm going to go, can I edit it here? I'm going to delete here. Let's go back to here and do it. There. Great. This is a better one, right? So imagine I've got like name, height, weight, and IQ, because for some reason I think I can use people's weight and height to calculate their IQ. I don't know. And I've got 3 subjects. Sometimes CSVs have like a header row where it describes each column. Sometimes it doesn't. So I'm going to save this. I'm going to go back here, upload the new version, open it, make sure. Yeah, perfect. Looks good to me, right? Any questions so far? Everyone's happy? All right, cool. Now, so yeah, we could visualize it like this, like I just showed you. This particular CSV has a header line, which explains the columns. CSVs don't need these, but sometimes you have them. So how do you read a CSV file? Well, there are a number of ways you can do it, but if we were to go look at the file that are like the code I gave you in assignment 1, look at this, right? So what I'm doing is I import CSV. This is the special like library that makes it easy to read CSV files. And by the way, there's a lot easier way to do this. I'll show you in a second. But what I do, I open the file the regular way, but then I create a CSV reader and I give it the file. Now I have a Starbucks file reader, then I have Starbucks locations. For each row in Starbucks file reader, I take that row at index 0 and 1 to convert them to a float, because what type is it going to want to read numbers as? Well, we want them to be numbers, but whenever you read anything, it's going to assume it's a string, right? So we got to turn them into floats. And then I save them in a tuple for some reason, and then I append it to my location list. And I'm done. I close the file because I'm good. Cool. There we go. That is like an easy way to read from a CSV. And then we would end up having a nice list of tuples, where each tuple is the contents of the row, and each index in the line is each row. Pretty neat, pretty handy, easy peasy stuff. There's also a much easier way where you can do, it's going to be a hell of a line of code, but I'll show it to you anyways. I can say like A equals the list of, okay, I got to import CSV. CSV.reader, open, and then .csv. There. And then, hey. Oh, what did I do wrong? Can't read in, yeah, that's a typo. Boom. So here's an even easier, quick and dirty way of reading in a CSV. This wouldn't have worked cleanly in assignment 1 because I had to like convert types. But you can see here that what did it do? Well, I've got a list of lists where the outside list is each row, each line, and the inside lists are the strings corresponding to each value in each column in its respective line. Pretty neat, right? Handy stuff, simple. And like, how did this work? Well, it turns out when you tell the CSV reader to convert itself to a list, it just knows what to do. Someone coded it that way, but so it works this way, which is really nice. Anyways, that's how you do it. So to emphasize line, loop is the trick to reading a file from a CSV reader. Yeah, you can iterate over a CSV reader where it'll give you each row. Okay, and each row can be a list of the columns for each value if we were to do it this way. Yeah, cool. All right, here's an activity. Another one, activity heavy today. Download the CSV file to your computer, then upload it to Colab. Write a function called load airports that loads the CSV file into a list and returns the list. Use the load Starbucks data as reference, and then play around with the data a little to get a feel for how the information is stored in your list. So I'll give you a few minutes to work on this one. What's up? Yeah.
I'll be back.
Okay, hold on. I'm just going to pause this. Now here's my solution. I could have made this a lot simpler, by doing what I just showed you, but like list of the CSV reader open, and boom, I'd have it. But I wanted to do it this way to make it more explicit, and also it'll make the next activity a little easier. But what's going on here? Well, I made def load airports data. I gave it a file name. I open the file name in read mode. Then I give that immediately to a CSV reader. I create an empty list called airports. That's where I'm going to put all of my airports. And then for airport in CSV airports, that's this thing here. Airport, based on how the CSV reader works, airport is a list of the 2 elements in that row. So I could just take that list and append it to airports. And once I'm done doing all that, I return airports at 1 to the end. Anyone want to take a wild guess why I did 1 to the end? It's not entirely necessary here. I just did it. I'll show you what happens if I don't. Oops, what did I do wrong? That's what I did wrong. There. Can you see the difference? The element at the beginning is that like header. I didn't care about the header, so I just say like, okay, return it, but I know the header's there, so just give me everything except the first line, or the 0th line, right? So there we go. Now we have a list of pairs. ABE, well that's Allentown, Bethlehem, Easton, right? ABQ, Albuquerque, and so on and so on and so on. Neat, right? Cool. Any questions about this? Now, the next activity is like, okay, if I were to tell you to write the code get name from airport code, where the function will take the list of airports and an airport code, and you got to give back to me the full name of the airport, right? You should at this stage immediately be thinking, well, that's a linear search, right? Search through until you find an equal code, and then don't return the code, but return its pair, its respective name. Okay, yeah. So I can do that real quick here. So let's say I have like def get name from code, airports code. All right. Okay, for in airports, if airport at 0, because index 0 of each individual list is the airport code, equals code, return airport at 1, because it was always 0 was the code and 1 was its full name. And if I ever get to the end, there. Cool. That should be it. And then airports, and let's give it like YYZ, right? Boom. Awesome. It worked. This is just a regular old linear search, right? What I want to find, the collection of things. So for each thing in there, airports at 0, which is always going to be each individual airports, because each airport is represented as a pair of information, a list with 2 values. 0 is its code, and 1 is its name. So if I find the matching code, return airports at 1. And if I ever get to the end, I'll return like a sentinel value -1. But based on everything we've learned so far in this class, can you think of a better way to do this? I'll give you a hint. If I have 100 airports, how many airports do I need to look at to guarantee I find it or not? 100. If I have n airports, how many do I need to look at? N. Yeah. Can anyone think of a better way? A dictionary would absolutely work here, because each airport code is unique. That's perfect for a key. So maybe what I should do here is say, instead of making airports a list, I should make it a dictionary. Then I can say, oops, airports at the key, which is airport at 0, because that's the code, is equal to airport at 1. And then here, just return that. Now this won't work because it's going to try to search a dictionary as it was a list, but that doesn't matter because I don't even need this anymore. I don't need that whole function. I just do airports at YYZ. Boom. Awesome. I did that pretty quickly, but it's still awesome nevertheless. So dictionaries are amazing. Cool, cool, cool. Airport code is unique, so why not make that the key and have its corresponding name the value? Any questions? All right, I'll see y'all later.